This is the video podcast for Chapter 12 in Field Methods in Hydrology, and the topic is Dataloggers. We've always needed to collect data about the environment, and usually that involved just manual methods, go out and observe and see what's going on. Well, that really started to change when people started to come up with imaginative ways, mechanical devices especially, to try to have records of information that they didn't directly observe. And that particularly reached a peak in the later part of the 20th century when there were wind-up devices, and I'll show you the gold standard for that. But in the latest part of the 20th century, especially since 1980, and in the 21st century, we've seen a complete overhaul of that infrastructure with computerized, microprocessor-driven data loggers. Well, the technology that existed, in the mid to late 20th century was dominated by a device called the Stevens chart recorder, and really any kind of chart recorder. What a chart recorder consisted of was first a wind-up clock, and it's shown in the innards of this box here. So basically, just like you'd have of a watch, you're winding it up, and then that has the appropriate mechanics in it to track time. But as part of that wind-up clock, there's also then a drum that's spinning like a scroll, and so that's turning paper from a source side to a receiving winding up side, just like an old tape recorder, but just with paper. So that's the part of it as to the ability to record information on a paper. Now, what about the environmental signal? What was needed was a way to take whatever is happening in nature, some natural phenomenon, wind, water, temperatures, whatever it is, and turn it into mechanical work. The simplest example in hydrology is the case of a water level recorder, as shown here. What you can see is a big cylinder that's actually afloat, so it's less dense than water, and it floats on a water surface like in a well or in a well or tank that's adjacent to a river, or it could be in a stilling pond associated with a weir of some kind. And so as that rises and falls, then the use of a pulley with this either metal tape or cable is used to spin this wheel. So you're taking this vertical change, converting it into a rotation through this axis, and then that is sending it in to then be transferred through a bunch of other gears to a pen. And so that pen is moving back and forth across the paper that you see in the upper right of this photo as a result of water levels going up and down. So through really interesting mechanical means, there was the ability to transfer a natural signal to mechanical work to something that's documented on paper. Usually the clock could run for a week, so once a week someone would have to come out, usually recover that piece of paper, put in the next piece of paper, and wind the clock, just close it up, keep everything oiled and in good working condition. And that was the primary job of a hydrologist in the field after installation, was to basically just get out there regularly to keep the thing going. That's changed now with the advent of the microprocessor-based data logger. So a data logger is a device that's just capable of collecting data and then keeping it, but the key is that a site is unobserved, unattended for a long period of time. This has trade-offs, of course. There's a lot of value in being able to get out there and observe things. You learn so much from being in the field, playing in the field. But at the same time, we can't be there all the time. Even at night, we have a limited ability to observe, but I always say Murphy's Law of hydrology is that floods come at night. Or things may happen over such a long period of time, you just can't notice them, and you certainly can't be there over a long period. So, and then there could also be many different locations that you'd want to observe all at the same time. So a data logger simply substitutes capital for labor and allows us to, collect large amounts of information from many sites all at the same time at a much lower cost than it would be if we had to pay people to go out and do all of that individually. Of course, there's many applications for this far beyond hydrology, but within hydrology, weather is a cornerstone kind of information we would want, groundwater monitoring, and just really any kind of water levels, which also would include from stream gauging, because you can recall from the discharge lecture that there was the rating curve, and that's based on stage gauging, or whether that's at a weir or just a regular river cross-section, soil moisture conditions, a whole bunch of things that are out there. And here's a photo that just shows a typical installation. You can see that there's some sort of pole mounting system with guide wires that are here to hold everything up. There's a variety of sensors on here. We'll be looking at weather stations later in the quarter in more detail. In addition to the sensors, you can see a solar panel that helps to provide energy. And then there's this brown bronze box near the bottom, which is a weatherproof enclosure that allows data to be collected into the computer that's inside that box, safe and secure from the ambient moisture. There are many data logger manufacturers. There are many that are just for the environmental industry, and I've listed some of those here. There's many more than are here, and I haven't really tried to list these in any particular order, just try to put a whole bunch down, and these can come and go. What's really changing in the 21st century is not only the availability of these established companies, but the attempts to make very low-cost systems that are really using more generic computer technologies, things like Raspberry Pi, with the intent to just have far more distributed environmental monitoring at even reduced cost. Some of the challenges with these devices, though, is that when you're dealing with the outdoors, you just fundamentally need some level of rugged, protection. And my experience has been that it's generally difficult to make something as rugged and protected and secure, high quality on your own as it is to do what all these other companies have done. A key factor is that environmental sector is not a huge sector compared to others, and so as a result of that, there isn't much of an economy of scale. This is something I think I mentioned with the velocity sensors as well. Just when you have a relatively small market, then you don't have as many players, and as low cost, because you just don't have that economy of scale. So those are some of the challenges in general that you have to be mindful of, and these, this will continue to change. For example, we may see over time that devices like tablets and smartphones may get so many sensors on them that they effectively can function as data loggers. They already have time-lapse photography capability. They can track individual health, and there are other sensors that are available, so it's moving in that direction. And maybe someday we'll see that as a replacement. But there's a lot of merits to a traditional data logger, just in that people have put a lot of time into thinking through what's needed to have an effective, safe, secure approach to monitoring in typical field conditions. Okay, the components of a data logger. First, you have to have the computer itself, right? So that's the microprocessor brain of the unit. And here I'm just showing 3 different examples of data loggers. The one on the left just looks like it also has a huge readout, of course, this hobo from Onset, where these other ones are a more traditional version. These are data loggers that are designed for great flexibility in terms of what you do, these 2 on the right. So they have a generic brain inside of them. There needs to be some amount of programming to go with that. And then they can receive information from all kinds of sensors. And that leads to these lines that you see here, green lines on the Campbell Scientific Logger and black on this Global Water one. These are what are called the termination or termination strips. These are the places where you're going to plug sensors in. In both of these cases, you're going to have just regular wires that you have to then, you push into the hole and then turn these little screws down to hold them in place. Others have more turnkey solutions where you just, maybe just like a plug. So you just literally plug it in. But when you're plugging it in, then you're usually locking yourself into a brand and the sensors and stuff that they have, which isn't bad. I mean, you're in that ecosystem and you're going to stick with it. Whereas these more generic loggers can take all kinds of different inputs. Data loggers also need batteries because clearly you need a source of power. You have to have a weatherproof enclosure, not shown here, to keep things dry. There's going to be the sensors and then some way to install the sensors into the environment. For a weather station, you saw it could be just a pole with some cables holding it up. But when you look at a river where it could be substantially more aggressive, that kind of housings and installation materials can be far more extensive and involve a lot of construction. Data loggers have what we call channels and counters. These are the features that record the information that you're getting from the sensors. And they come in different flavors. I'm highlighting 4 different flavors here. The most common one that you see is called an analog channel. An analog channel continuously records an electrical signal, which is a voltage. So it's recording that through time. And what this means is, like, whereas a Stevens recorder was taking some environmental phenomena and turning it into mechanical work, so the movement of a pulley, for example, what an analog channel is doing is it's taking an environmental phenomena and turning it into an electrical work, an electrical signal, basically, a voltage. And so if the voltage goes up, it means something's happening in that environmental process. If it goes down, something else is happening or something is stopping. Again, if we stick with the water level, usually you'll find like the water level could be 0, so you might have a voltage that goes from 0 to 5 volts, which could represent a range of 0 to 10 meters, let's say. And so each increment of voltage would represent an increment of increasing water level. That means you're going to need a calibration to convert from voltage to water level, but that's a topic we'll get into in a different presentation. In addition to an analog channel, there's a digital channel or pulse counter. What this is doing is it's recording a discrete number over a period of time, typically a count of events. And the tipping bucket rain gauge would be the quintessential example here. So anytime an event triggers, like on, off, yes, something happened, or no, it didn't, then the yes, something happened is registered as an event. And you might have a date and time and a 1, like yes, this happened. And so then every event just is given that timestamp and recorded in the logger, and that's called a pulse counter. A switched excitation channel is one in which power is provided from the data logger to the sensor, and that could be done on a time basis, like every day turn on at 10 o'clock in the morning and do something. Or usually not do something, but provide the power and then record the result. Alternatively, it could be you could have a rain sensor or a moisture sensor, and it could say, well, when relative humidity or precipitation or water level, something happens, then start recording, and when it stops happening, stop recording. Finally, there's something called the Serial Digital Interface at 1200 baud transfer speed, known as SDI-12, that is a generic interface that's, can allow you to take a sensor from most companies and put it into most other companies' data loggers through this SDI-12 interface. The Datalogger data itself is essentially, you need to understand a little bit about how computers work. And it really is important because this gets to the issue of precision. Accuracy is going to be more a function of the calibration, converting the voltage to water level or temperature, whatever it is. But the precision you get is all governed by understanding how information is stored in a data logger or a computer. we can define a bit as a single 1 or 0. So remember, computers work in a binary language recording just ones and zeros. A byte is a sequence of ones or zeros, or a sequence of bits. So if you have a number, like 12.237, then that number has to be converted um, into a set of ones and zeros. When we say 8-bit, then that means a byte with 8 ones or zeros. And we can have 2 to the 8. Well, if for example, right, okay, so because it's binary, you're recording either a 0 or 1. So that's 2 choices. And if we say 8-bit, then we can find out how many possible values we can record with 2 to the 8, which is 256. So that's telling us that with an 8-bit system, we can record up to 256 different pieces of information. So if we have a signal, and let's say it's a voltage that goes from -5 to 5, so for example, something that's bidirectional, like wind direction or wind speed or something, that's a 10-volt range. So across that 10-volt range, we can record up to 256 increments, which means we have a maximum resolution of 0.039 volts. So that's the key to understand, is that how much precision you get along your calibration function is going to depend on whether it's an 8-bit, 32-bit, 64-bit, whatever that is, 16-bit. That's going to guide the resolution you get for any fixed range. If you want to have more precision for a fixed range, you have to invest in a computer that has more bits assigned to each number. The type of memory that's available to store the information is pretty rudimentary on a data logger compared to a computer or smartphone. I mean, we're not talking about videos and audio and all kinds of stuff. We're generally just talking about raw numbers. And typically, a data logger has random access memory, RAM, and that requires a battery. That is where the memory is stored, is usually in RAM. So you have a battery, and there can be the overall large battery that runs the whole system, and then there can be like a small little LR44, these little jewelry sorts of batteries that can be used to just maintain the data against all other failure. In addition, a data logger is going to have some fundamental programming built into it, what we call ROM of some kind, or EEPROM, electronically erasable and programmable read-only memory. So this is, read-only memory. It's like it's locked on to the system, but usually these days there's some kind of way to upgrade that firmware and give it new information. This does not require a battery backup. In addition to the RAM that comes with the system, some data loggers will allow you to plug in additional memory cards that you can buy on your own. PCM-CIA is an older style. SD, micro SD, super micro SD. I mean, there's all these things that are changing there, but that's very common today. And even USB flash memory, memory. So this allows you, in a less expensive way, to add memory, because you can buy those generically on the open market, where there is an economy of scale because the same kind of memory is used for lots of computer applications compared to the RAM that's built into the data logger. Let's try to understand data logger memory requirements. Usually each data logger manufacturer will provide you with a manual or information specific to the data logger you've got. But to just give you a feel, 1 megabyte of memory can record roughly 520,000 points. That's just a very rough guide. So what you can see, if you have 4 sensors recording, each recording one variable every 15 minutes, you'd have about 3.7 years of capacity. And that's just 1 megabyte. Now, some data loggers are still unfortunately coming with like 256K, which is embarrassing. I mean, it feels like the standard should be at least 1 megabyte or much more. But it just shows you how challenging the finances are in trying to market and compete in a relatively small market. So it doesn't take a lot of memory for a data logger, and thus, memory shouldn't be the limiting factor in the decisions that you make about, what you're going to do. But just be mindful, like don't just accept the default. Make sure you check the specifications for your data logger, and that has at least 1 megabyte or however much more above that to record what you need. It also depends on how often you're going to go out, and I certainly wouldn't recommend leaving a data logger there for 4 years and never going. I mean, that wouldn't fly anyway. But in general, memory is not the limiting constraint. Instead, it tends to be power. Data loggers, they don't necessarily require a lot of power, but they definitely require power, and in my experience, it is power that limits how long a data logger can sit. And in some ways, that's not all bad because, again, it's good to go out and see the data, see the site, maintain equipment, keep things operational. Most data loggers have 12-volt batteries, but more recently, with very small data loggers or kind of like user-hacked sort of cooked up systems, maybe they'll only have AA batteries, C batteries, D batteries, or rechargeable packs of batteries, which is usually proprietary in the sense that the data logger manufacturer has taken some batteries, put them all together with some simple wires, and then taped them all up, and then they sell you that as a battery pack at 10 times the markup compared to just buying the D batteries off the shelf. But nevertheless, what I like to see is something that's going to have a pretty long lifetime. If you have a generic data logger with lots of channels, you're going to want to go with a 12-volt battery system because 12-volt batteries are the standard rechargeable batteries that come in a wide variety of sizes. There are many battery stores in local area as well as purchasing over the internet where you can buy what we call deep cycle batteries. These are batteries that are intended to be charged up, drained all the way down, and then charged up again. A car battery is not a deep cycle battery. That's why, like, if you leave your power on in your car, you may have to replace the battery after that happens just 1, 2, 3 times. Whereas a deep cycle battery or a deep cycle marine battery for very large installations, those batteries can be cycled up and down 1,000 times or more. Typically, a battery that is like a 7 amp hour battery is going to be pretty good for most applications. So a 7 amp hour battery provides 1 amp for 7 hours. But data loggers usually don't require an amp. They might require a milliamp. So it's relatively low, and therefore they could go substantially longer than just 7 hours. How much you need will depend on the wattage of what you're doing and the volt. So you kind of have to work out a little bit of this electrical information for the specific sensors. And again, most data logger manufacturers have manuals that help you to understand how much power the data logger draws and the sensors will draw so that you can work out pretty well how much battery you're going to need for however long you want to wait between replacing the batteries. It is possible that you can use solar panels, but it's important to remember, like, if you're whenever you have rain, which is when you want to record things hydrologically, runoff or storms or whatever, you're going to have a lot of cloud cover. Or if you're putting something in a canyon, there may be times of the day when the canyon walls are shading your solar panel. So solar energy is not a really viable solution for a lot of cases. It can be a supplement, it can certainly help, but it's more important to have a substantial battery that can pretty much survive the duration that you want to have. At this day and age, you're not going to go throw out some $500 solar panel in a place where there's a high risk of vandalism or theft. Datalogger software, it's been changing a lot. Um, in general, each manufacturer has a unique language for their own data logging, and that can be a little bit annoying. But most software is designed to be very user-friendly, where there's a range of sensors that goes with that data logger from that company, and they have pre-programmed, a user interface that's fairly easy to use to go with the sensors. However, if you're bringing sensors in on an SDI-12 or some other way, then you could start to run into problems with the pre-programmed tools that are available. However, a simple logging program could be saying, okay, let's create a logging plan in the software. So I'm going to specify a project name. You'll specify the recording interval. So if I'm in a well, it might be once a day. If I'm in a river, it's typically going to be 15 minutes. You have to then say, okay, here's the kind of sensor I have. And once it, that could be a drop-down list or something. So once you've picked the sensors, it knows the information about that and it can go. Sometimes the simple logging, the calibration for a specific sensor is known either because the sensor can communicate that to the data logger or it's pre-available in the data logger. But in other cases, you either have to put it in, you either have to do an on-the-fly calibration in the software, or you just have the freedom to enter your own calibration information. Complex software is generally a programming language, and that sounds like it could be a lot of work, but if you make a commitment to a particular brand of data logger and you go, you learn their language, then that becomes your go-to thing, and that gives you tremendous flexibility in terms of how you record and what you record. It's just that you have to, you could go get specific training from that data logger manufacturer. Now, what you do with the data when it comes out, of course, a data logger company is going to want to try to capture the application end of your business as well. So they may already have ways of taking the data natively from their data collection software into data analysis platforms. However, I always like to be able to get the data out to a very generic format, and that would be a simple comma delimited text file. So just, like each row, maybe the first row is the titles, and then the second row is the first piece of information like date, time, point ID, temperature, water level, whatever, all separated by commas. And that's called a .csv format. That's a generic format that both Macs and PCs are well aware of, and can easily be imported into Excel or other spreadsheet software without any problem at all. Datalogger Enclosures. So when you have a computer and the computer has to go out in the field, you could try to make the computer as rugged as possible, but an alternative approach is to simply make some kind of housing for it that you can put that in, and then allow the sensor wires to pass into the enclosure but still otherwise keep it sealed. You have to decide if this is going to be an airtight seal or just a watertight seal, and what level of seal there is. Some sensors require atmospheric pressure inside the enclosure, which means they can't be fully sealed. But what you can see is a pretty hefty plastic enclosure. Could also be metal if you want to increase protection from vandalism. And this is a fairly standard plastic box enclosure. The one on the right would be taking a ruggedized case and basically just mounting into that and treating that as an enclosure. And another thing you can see here, there are these like weird little packages here. What these are packages of silicone materials that are highly absorbent of moisture. And so they just throw a couple of these packages in, and that way they will absorb moisture. Sometimes these packages can be reused, like take them back to your lab or office or home, put them in an oven to dry them all out again, store them in a sealed bag or something, and then put them back in the enclosure. Other times they're meant to be disposed and just replaced. You could also see at the bottom here there is an opening that allows sensors to go through. Usually these have like screw-on press fit fittings, so that if this is a cable, if my finger's a cable, then it's going to be able to squeeze tight on that so it can go through, but it's going to be a tight fit. And the one on the right with this red box, you'll see two gray knobs on that. That is another one of these tightening, with a rubber gasket to seal it. And there's two, one for each sensor, whereas the one on the left is just one large opening, and you have to put as many wires through that as you need. Data log tripods and towers. This is where you start to get into a little bit more serious side of the installation aspect of it. If you're in a weather situation, you need to be off the ground. A tripod would be the smaller, more simpler installation. You'd probably still want to have concrete footings for each foot, or just very long rods to go through the soil if you're just going to be mounting it on the dirt. Usually you want to mount it level. So you need to size this to hold all of the sensors that you need and other materials that are going to be on there. With a full tower, it's a whole nother ball game. I'm not highly experienced with that, but you can imagine then you have to start worrying about, am I going to be in any sort of FAA, airplane regulation issues? Of course, always worrying about lightning, and really mounting this to the ground so that it's not going to fall over, with appropriate concrete and guide wires and so forth. Okay, before I end, I also just want to say that one of the main issues that comes up with the field use of data loggers is vandalism or theft. When you're putting things that, while not tremendously expensive, in the hundreds to low thousands of dollars, are still highly attractive to people. And even if you're on private land, if you're in a place that is highly accessible to people, even if they're not supposed to be there, there's a very high risk of theft, and you really have to plan for how you're going to handle vandalism, or if not vandalism, like a natural disaster kind of event. So if you're monitoring a river, what are the chances that your data logger is going to get inundated and potentially ruined? So just being, there's a whole nother sort of realm of thinking about data loggers from those perspectives. Painting them with camouflage paint, burying them underground, or just trying to decrease visibility, or just if you're going to have a tower, trying to make it blend into the environment to just not be an aesthetic nuisance. So those are some of the other factors to think about too. And we'll be playing with the data logger in the in the laboratory. But this gives you an introduction to the basic ideas associated with data loggers.